Before a tower touches the sky, it must first conquer the desert below. Engineers study the Earth, measuring its strength, its weakness, its history. Every meter of depth determines how high this structure can safely rise.
The solution is clear: deep piles anchored into bedrock. Exactly. This grid shows the precise layout for the piles. Understood? We'll proceed accordingly.
Each pile descends deeper than a 20-story building stands tall.
Easy now, hold the tension steady. Lowering steady, watch the alignment. Good, got it straight in.
Liquid stone fills the earth, locking the foundation in place. The base is secured. Tomorrow, the real structure begins. The materials begin their journey across the desert. Every oversized component moves with calculated precision. Thousands of connections will hold this tower together. Concrete supply must remain constant, uninterrupted. The machines that will lift the skyline arrive in pieces.
Crane, lift this bundle!
Reinforcement steel prepares to strengthen the core. Even the future exterior waits its turn. With supplies secured, the site transforms into a vertical workshop. In 2026, this site becomes the foundation of ambition.
All right, hazard board first. Heavy lift zone is active today.
Exclusion zones are posted, load paths clear.
Good. Check the lift plan details here. Look solid. Every operation begins with discipline.
The lifting systems prepare to shape the skyline. The lifting systems prepare to shape the skyline. Protection against moisture begins below the slab. Steel networks prepare to carry unimaginable weight. At the center, the spine of the tower takes form. The first vertical concrete will define the tower's rise. Inside the core, the tower begins its vertical climb. Clean surfaces ensure structural accuracy.
Radio check. We're live. Copy. Starting the vertical check. Beams climbing. Looks good. Confirmed. Within tolerance.
Every connection point is planned years in advance. Access systems rise alongside the structure. Power feeds the machinery that feeds the tower.
Clips are on. Running the line to the panel. Copy. Panels prepped for connection.
Vertical logistics become the building's lifeline. Level by level, the core advances upward. The core climbs using hydraulic precision. Reinforcement prepares for another ascent. The exterior frame begins to define the tower's outline. Each connection absorbs the forces of height. Steel and concrete integrate into a unified structure.
Beams align! Bolted down!
Even at night, progress does not pause. Every floor creates the next working stage.
Next beam coming down! Clear the area!
In 2026, the skyline of Saudi Arabia begins to change. At this height, millimeters determine long-term stability.
Lift and rotate, steady. Swing right, taglines on. Aligning with core, hold.
Outrigger systems transfer lateral forces into the outer frame. Each bolt carries engineered force paths. The central core advances one level at a time. The vertical frame extends steadily toward the sky. Material flow must remain uninterrupted at all elevations. Temporary systems ensure safety before permanent rigidity is achieved. The structure now behaves as a unified vertical system. As the tower rises, the cranes must rise with it. Every lift follows calculated load parameters.
Operator, confirm load is steady.
Confirmed, lowering to connection point. Embedded sensors monitor stress in real time. Wind behavior is measured continuously at height. Material consistency is controlled by calibrated systems. Vertical logistics reduce time between levels. Automation improves placement accuracy. Progress continues beyond daylight hours.
The facade begins with structural anchoring. Panel ascending, taglines taut. Compensating left sway, hold steady. Approach brackets, final tension.
Installation tolerances remain within millimeters. Sealing ensures resistance against heat and sand infiltration. Energy efficiency begins inside the envelope.
Performance is verified before final progression.
The exterior surface begins defining the tower's identity. The tower now transitions toward its upper structural phases.
Every structural joint undergoes verification.
Concrete performance is measured against design standards.
It's holding, strength is climbing.
Pass the threshold. It's a pass.
Envelope systems are tested under simulated conditions. Wind response is continuously analyzed. Vertical transport systems demand exact calibration.
Left rail aligned. Fastening now. Right side matches. Laser confirms.
Proceeding to next section.
Environmental systems are balanced floor by floor.
Initiating pressure test. Opening the valve. Pressure is holding steady. Closing the valve. Test complete. Safety systems are verified before occupancy.
Structural completion approaches its final stage. The final structural connection. Is secured.
Temporary systems give way to permanence.
The building transitions from construction to operation.
Voltage stabilizing. We're in operational mode.
Vertical transport systems enter active service. From desert ground to skyline dominance.